The confirmation of 3I/Atlas as an interstellar object marks a rare and scientifically significant moment in modern astronomy, expanding humanity's understanding of how material from other star systems can traverse the vast emptiness of interstellar space and briefly pass through our own solar neighborhood. Initially known by the provisional designation A11PL3Z, the object immediately drew intense attention from astronomers around the world due to its extraordinary speed and unusual trajectory. Moving at approximately 152,000 miles per hour, far faster than most native solar system objects, it appeared to be traveling on a path that was almost perfectly straight and remarkably flat compared to the typically curved or elliptical orbits of asteroids and comets bound by the sun's gravity. This distinctive motion was the first strong clue that the object did not originate within the solar system, but instead came from beyond the sun's gravitational influence, likely having wandered through interstellar space for millions or even billions of years before its chance encounter with our star. The story of 3I/Atlas began when it was first detected in late June by the Asteroid Terrestrial Impact Last Alert System, commonly known as ATLAS. This automated survey system continuously scans the night sky using a network of telescopes strategically positioned in Hawaii, Chile, and South Africa. ATLAS is designed to identify potentially hazardous near-Earth objects, but it also excels at spotting unusual or fast-moving bodies that stand out against the background of distant stars. After the initial detection between June 25th and June 29th, astronomers quickly searched archival data and found earlier observations of the object dating back to June 14th. These additional data points helped scientists calculate its speed and trajectory with greater accuracy, confirming that it was moving far too fast to be gravitationally bound to the sun. As news of the discovery spread, both NASA and the International Astronomical Union officially listed the object as confirmed, triggering a wave of excitement and speculation within the scientific community. Early assumptions suggested that A11PL3Z might be an asteroid, similar to the first known interstellar visitor, Oumuamua, which passed through the solar system in 2017. However, as more telescopes around the world focused on the object, subtle but important details began to emerge. Observations revealed what appeared to be a faint surrounding cloud of gas and ice, known as a coma, as well as a possible tail extending away from the object. These features are classic indicators of cometary activity, suggesting that the object was heating up as it approached the sun and releasing volatile materials from its surface. On July 2nd, NASA officially confirmed what many astronomers had already suspected. The object was indeed interstellar in origin and would not remain in the solar system for long. With this confirmation came its official designation, 3I/Atlas, making it the third interstellar object ever identified passing through our solar system. Its full cometary name, C/2025 N1 Atlas, reflects both its classification as a comet and the survey that discovered it. This reclassification was particularly significant because it challenged the initial assumption that the object was asteroid-like, highlighting instead that interstellar space may be populated with icy bodies similar to the comets that originate in our own distant or cloud. The discovery of 3I/Atlas follows in the footsteps of two previous interstellar visitors that fundamentally changed how scientists think about the solar system's relationship with the wider galaxy. The first, Oumuamua, was detected in 2017 and immediately became one of the most controversial astronomical discoveries of the century. Its elongated, cigar-like shape and unexpected acceleration led to widespread speculation, including the sensational idea that it might be an alien probe. Although subsequent studies strongly suggested that Oumuamua was a natural object, likely propelled by outgassing of hydrogen or other volatiles, it nevertheless revealed how little was known about objects originating beyond our solar system. The second confirmed interstellar visitor, Comet 2I/Borisov, was observed in 2019 and behaved much more like a traditional comet, complete with a well-defined coma and tail. Borisov provided the first clear evidence that other star systems can produce comets very similar to those formed around our Sunday 3I/Atlas. Now, adds a third data point to this extremely small but invaluable sample of interstellar objects. Each new discovery helps astronomers refine their models of planetary system formation and evolution across the galaxy. Scientists have long suspected that countless interstellar objects pass through the solar system unnoticed, simply because they are too small, too faint, or too fast to be detected with current technology. The fact that ATLAS and other survey systems were able to identify 3I/ATLAS suggests that improvements in sky monitoring capabilities are beginning to reveal what was previously hidden. This raises the exciting possibility that interstellar visitors may be far more common than once thought, offering regular opportunities to study material from other star systems without the need for interstellar travel. Despite the growing body of observational data, many details about 3I/ATLAS remain uncertain. Its exact size and shape have not yet been determined, though current estimates suggest it could be as large as 12 miles, or about 20 kilometers, across. If this estimate is accurate, it would make 3I/ATLAS significantly larger than both Oumuamua and 2I/Borisov, potentially providing a much richer source of information about its composition and structure. However, determining the true size of a comet is notoriously difficult, especially when it is surrounded by a coma that can make it appear larger and brighter than the solid nucleus actually is. What is known with greater confidence is the object's future path through the solar system. At present, 3I/ATLAS is located at a distance roughly 5 times farther from the Sun than Earth is. As it continues its inward journey, it will reach its closest point to the Sun, known as perihelion, on October 30th. At that time, it will come within about 1/4 astronomical units of the Sun, meaning it will remain slightly outside Earth's orbital distance. Importantly, there is no risk of collision with Earth. Shortly before reaching perihelion, the comet will also make a relatively close pass by Mars, coming within about 0/4 astronomical units of the red planet. While this is still a vast distance in human terms, it is close enough for orbiting spacecraft and ground-based telescopes to conduct detailed observations. The scientific value of these observations cannot be overstated. Because interstellar objects formed around other stars, they effectively serve as time capsules, preserving information about the chemical conditions and physical processes that existed in distant planetary systems. By analyzing the light reflected and emitted by 3I/ATLAS, astronomers hope to determine its composition, including the types of ices and gases it contains. Comparing these findings with data from solar system comets could reveal whether the building blocks of planets and life are similar throughout the galaxy, or whether our solar system is in some way unique. Beyond its scientific importance, the passage of 3I/ATLAS captures the imagination by highlighting the dynamic and interconnected nature of the universe. The idea that a comet born around another star can travel across interstellar space and briefly visit our solar system underscores how cosmic processes transcend individual star systems. Each such encounter is a reminder that the Sun and its planets are not isolated, but part of a much larger galactic environment where material is constantly exchanged. As 3I/ATLAS continues its journey, astronomers around the world will be watching closely, using some of the most powerful telescopes ever built to gather as much data as possible before it speeds away, never to return. Once it exits the solar system, it will resume its lonely voyage through the galaxy, carrying with it a record of its brief encounter with humanity's instruments and curiosity. For scientists, the discovery represents another step toward understanding the diversity and abundance of interstellar objects. For the rest of us, it is a humbling reminder that even as we look up at the night sky, the universe is constantly sending us visitors from far beyond our own cosmic backyard.